Good afternoon, good evening, and good morning, wherever you're watching from. I am Paranormal Ripples, aka Ray, and welcome back, everyone, to another episode of Secrets of the Stars. This is episode 12, and today we're going to be diving and driving with phenomenal force here into an intriguing topic known as the Drake equation. If you don't know what the Drake equation is, it's an equation that attempts to calculate the probability of intelligent life in our universe. It's complex and thought-provoking, and it was done in the 60s by a bloke called Frank Drake, and it has captivated the minds of scientists and enthusiasts alike for decades. So, ain't about, and I'll explain to you what it's all about. And if you like what this is about, and even more topics, hit that subscribe button, hit the notification bell so when I go live, you're always up to date with it. Also, go back from my back catalogue of shows and to see what you like. Also, hit the comments and tell me some stuff that you would like me to talk about. And yeah, let's crack on with the Drake equation. So, the Drake equation. As I said, it was done by a bloke called Frank Drake, Dr. Frank Drake, an astronomer. I'm going to just show you my screen now. In 1961, this guy come out with it. There he is nowadays. Well, in 2017, I don't know if he's still with us. Quick Google search. No, he passed away in 2022, sadly. But he was 92. So, he had a good innings. As we'd say here in this part of the world. But yeah, what if we could talk to aliens? He said. You gathered a group of scientists, to talk about how many alien civilizations could be living in our galaxy. To help these scientists think, he made a mathematical equation which predicts the number of intelligent alien civilizations in our galaxy, the Milky Way. And scientists can put their own numbers in for each term in the equation, and each number in the equation is just an educated guess. So, when he done the equation, he done R times, our star, so it's our stars made up in our galaxy in 1 year, FP, the fraction of stars that have planets, so like we have our planet, like Jupiter, stuff like that. NE, the fraction of those planets where life can exist. So there's us, there's probably Mars, there's Jupiter, maybe. The fraction of those where life does exist. So us, which is FL. So there's definitely life on here, on Earth, isn't there? FI, the fraction of those planets where intelligent life exists. Again, you can minus Earth. I presume. I think you could do that. Mars might have intelligent life. Fraction of those intelligent aliens who develop a technology that is able to communicate outside of their own planet. L is the number of years that an intelligent communicating civilization lasts. So then he goes R times all these, right, equals the number of intelligent aliens currently living in the Milky Way. So here's an example which they've given us here, right? 10, astronomers know roughly 10 stars are made a year, so they've put 10 in. 100% of nearly all stars are planets. 25% M3, life can exist in very harsh environments, so it would make sense that life could exist on a number of planets. So Neptune and Uranus, cold gas giant, not cold, free ice giant planets. Yeah, life could live there. 100% if life can exist, it will, FL. 1%, not all life will become intelligent. True. 50%, which is FC. Most intelligent life will be able to invent communication technology such as a radio. And L, a million years, is holding. So they've done 10 times 100% times 25% times 100% times by 1% times by 50% and times by the million. And it equals 12,500 intelligent alien civilizations, which may actually exist. This is just a guess, but it shows why some scientists think it'll be easy to discover alien life. So he basically invented that equation to try and help people, like scientists, out, and I'll come up with this equation, use it going forward in your research. NASA, of course, come out with this article in 2016, 6 years before his passing. And they revisited it, basically. 2 researchers have revisited and revised the Drake equation at the University of Rochester in New York, I believe. Rochester University is the University of Rochester. I could be wrong. Yeah, Rochester, New York. So, right? So they've done this study and that, and the question of whether advanced civilizations exist elsewhere in the universe has always been vexed with 3 large uncertainties. Sorry. In the Drake equation, said Adam Frank, professor of physics and astronomy at the University of Rochester and co-author of the paper, we've known for a long time approximately how many stars exist, but we didn't know how many of those stars have planets that could potentially harbor life, and how often life might evolve and lead to intelligent beings, and how long any civilizations might last that just before becoming extinct. So they've gone and done it. Frank and the other guy, where was it? Sullivan. So rather than asking how many civilizations may exist now, we ask, are we the only technological species that has ever arisen? Woodruff Sullivan, University of Washington. So he's from the University of Washington. So the result, by applying the new exoplanet data to the universe's 2 times 10 to the 22nd power stars, Frank and Sullivan find that human civilization is likely to be unique in the cosmos only if the odds of a civilization developing on an habitable planet are less than 1 in 10 billion trillion, or 1 part in 10 to the 22nd power. And yeah, it is a really small number. Sullivan points out that the full Drake equation, which calculates the odds that other civilizations are around today, may give solace to the pessimists. Frankston. And then thanks to NASA's Kepler satellite, which was around in the atmosphere, and other searches, we now know that roughly 1/5 of stars have planets in habitable zones where temperatures could support life as we know it. So one of the 3 big uncertainties has now been constrained, and here's the Kepler planetary lineup. Look how small Earth is compared to that. You know, that's nuts. Could you imagine if we could get to Kepler 22b? That is crazy. But looking at it here, Kepler 62f and 62 and 69c, sorry, seem like there were 2 that look closest to Earth. Frank even said that the third big question, how long civilizations might survive, is still completely unknown. The fact that humans have had rudimentary technology for roughly 10,000 years doesn't really tell us if other societies would last that long, or perhaps much longer, he explained. Frank and Woodruff found that they could eliminate the term altogether by simply expanding the question. Here you go. And there you go. And then there's more about Frank here. Drake. There it is. The Drake equation has proven to be a durable framework for research and space technology as advanced scientists' knowledge of several variables, but it's still impossible to do anything more than guess at variables such as L. This one here, pardon me. The length of time that a civilization can last. The longevity of other advanced civilizations. And then they go, so they've done a new one, but they've decided to eliminate L. L is no more in their equation. Their argument hinges upon the recent discovery of how planets exist and how many of those lie in what these scientists call the habitable zone. Planets in which liquid water and therefore life could exist. This allows Frank and Sullivan to define a number they call NAST or NAST is a product of N star, the number of stars, FP the fraction of those stars that form planets, and MP the average number of those planets in these habitable zones of their stars. They are sent. They then sent out. They then set out what they call the archaeological form of the Drake equation, which defines a as the number of the technological species that have ever formed over the history of the observable universe, and then there's their equation. The universe is more than 13 billion years old. Oh, yeah. That means that even if there have been 1,000 civilizations in our own galaxy, if they live as long as we have been around, roughly 10,000 years, then all of them are already likely extinct, and others won't evolve until we are long gone. For us to have much chance of success in finding another contemporary, active technological civilization on average, they must last much longer than our present lifetime. If they were 20,000 light years away, then every exchange would take 40 years to go back and forth. And it's true. Like, I can understand why they would want to done it, but I wonder if they got anywhere with it, you know? If these hunters, they still use it. Why if their NASA still use it? They say. Because it seems crazy, doesn't it? You know? Seems crazy. No, and then there's the Fermi paradox as well. The Fermi paradox ponders why Earth has not been visited by aliens. I'll go into that in another episode. But the Drake equation, look, the University of Maryland, look. BBC Sky at night. This was done in January. This past January, look. There he was, look. In 2015. I find it interesting, this kind of stuff, you know. Like, how would you know for sure? I know you could say it does work. You're gonna be having to do stuff for such a long time with it. Obviously they could been like they don't obviously they found stuff with it, you know. No, we even done a BBC there was a BBC Four programme, look. It is absolutely crazy. Look, even National Geographic, look. Wow, everything. No, why alien hunters have spent 60 years finding new solutions for the Drake equation. So for 60 years they've been trying to. I'll come off now for a second. But yeah, for 60 years they've been trying to find a replacement for it. You know what I mean? So obviously they're trying to find some kind of um some kind of thing. Look, 60 years later, is it time to update it? Look. What do you guys think? Do you think we should update it? If it's only one that's working at the minute, then well with reform, then I would say keep using it. You start changing stuff around, and you're going to blooming. I don't know how far behind you're going to get, but there again, we're in this little age now where you could basically get everything. You know, AI might even come up with an answer. You know, I'm not saying it would, but could you imagine putting going into Chat GPT and go, come up with an equation that proves about aliens life, about the odds that aliens exist, you know? And he writes one. Like boom, there. Simple. Bang. I saw an AI joke on a few weeks back on that before and that which wanted me to probe about doing this one, but it was like something like why did what I put it into Chat GBT the other day. How do you know that that alien life is out there? And Chat GBT comes back with, well, it's on our TV shows, and so this person puts back, what do you mean? And they go, well, Doctor Who goes and picks up a random stranger every time and takes them somewhere, and I'm like, if something like that, and I'm like, if that was trying to be, I know it was like a joke thing, but could you imagine, you know, no, only one in a million has the right combination of chemicals, temperature, water, days and nights to support planetary life as we know it. And that's what we're in, a one in a million. That's probably why the planets that we're looking at are so far away, you know. It's like crazy, you know? It's flipping nuts. Anything. And then there's a book also about it, look, written by Bart King. No. Some intelligent civilizations could be trapped on their worlds. That's an interesting theory. Or they're just waiting for us to get there. But yeah. It's nuts. No. That is a nuts though, isn't it? Like, look, see, that's how they change it. Look, that's the original one. That's the one that they've gone with. It's crazy, you know. So let me know what you guys think in the comments. I'd love to hear your thoughts on this. Like the video if you've enjoyed it. Subscribe if you haven't already. Like I said, like I keep saying, I'd love to have you on board. It'd mean the world to me. To have a community to call my own. And yeah, thank you all for watching. Secrets of the Stars episode 12 and the Drake equation. Yeah, and I'll see you next time. And have a good rest of your day. Take care. Bye for now.